Unit 1, Lesson 5. So recall the following notes from Lesson 2. Remember, square roots. All positive numbers that have two square roots has one positive and one negative. Okay, square root of 25 is 5 and negative 5. Because 5 squared is 25 and negative 5 squared is 25. Okay, so that's what they're talking about here. Just the idea that there's a plus or minus. Cube roots can be negative. You can cube root a negative number because it's an odd index. Even square roots, you cannot square root a negative number. Okay? Any questions so far? All right. So on this here, complete the following statements. 4 times 4 equals 16. Okay, so the square root of 16 is 4. So we have that taken care of. We know what the square root of 16 is. Okay, how about the next piece there? So we have 5 times 5 times 5 is 125. So what's that referring to? The cube root, because there's 3 of them. Good. Okay. So we would put a 5 there, 4 there, 5 there. 2 times 2 times 2 equals 16, so the fourth root of 16 is 2. 2. Okay, 10 times 10 times 10 times 10 is 100 or 1 million. So the 1, 2, 3, 4, 5, 6th root. I'll just put 1m for 1 million equals 10. Okay. Okay, so mentally evaluate these. Okay, so we'll just pop around here. So Travis, what's the square root of 49? 7, perfect. Okay, Ridge, you want to try what's a cube root of negative 64?
Negative 8.
Close. Their square root would be negative 8. No. So you're getting higher. So it's going to be negative 4. 4 cubed 64. So that page, it's a couple pages back where it has the squares and the cubes. Remember, I said be familiar with those. Okay? So that one would be negative 4. Ollie?
How do you do those on the calculator?
The cubes, you have to hit, if you have the graphing calculators, yep, you have to hit math. Okay? Math. And then it's right there, the cube. Yep. It's on there. Okay, let's look at that for a second here. All right, so the C, fourth root of 10,000. Okay, so fourth root of 10,000. Well, how many zeros are there?
4.
So it's 10. Okay, fifth root of 1 over 32. When you're doing a fifth root of something, anyway, when you do a radical with a fraction, you do top and bottom. Fifth root of 1 is 1. The 10th root of 1 is 1. 1's just times itself, right? 32, well, to the 5th is 32. Well, it's going to be the smallest one. It's 2. 2 times 2 times 2 times 2, 5 times is 32. Okay, so this is 2. Okay, how do you do that in your calculator? Okay, there's a part, that same math place. You hit 5 first on your calculator, then you hit math. You pick the one with an x. That makes it fifth root it. Then put brackets, 1 over 32. Okay? But everybody needs to know here, whenever you're square rooting, any root of a 1 is 1. 7th root of 1 is 1. 12th root of 1 is 1. So that should be the easy one. Okay, 32 might take you a little bit, but just think about it. If we know that, what's 3 cubed? 2 cubes 8, but I know what you're thinking. What's 3 cubed? It's 27. 3 times 3 times 3, right? So like what I'm saying is, this can't be anything more than 2. If I do 3 times 3 times 3 5 times, we're really big. So there's kind of a number sense of understanding. Okay, I probably should try the easiest number possible, which is 2, which that's what it is. Okay, have a number sense, because if it's fifth rooted, it needs to be a pretty big number in order to be a bigger number. Can't do. Even, negative. So we can't do that one. Okay, it cannot be an even index and have a negative, so we can't do. So it's not possible. Okay, and then cube root of 125, that's on the cubes list. 125 is 5. So that's 2 times 5. There's a 2 out there. Now you multiply them. This one's answer is 10. Okay, if I go too fast in this, let me know, because we're doing this in Math 20 right now, so I might be glossing over things. If I'm not explaining something you want to know, let me know. All I showed you right here is cube root of 125 is 5. You'll see that on your list. Okay, on your list on that page, it says this. 5 cubes 125, so the cube root of 125 is 5 then, right? Okay, since that's there, it's a 5. You times these, you get 10. Okay? Any questions? Okay. Okay, so now it shows you how to do this stuff with the calculator. So this is what's coming. So press 4. Okay. Then you press Math to type this one in, and you choose the X one. I already explained this, and then you hit Enter. So when you push the number, you can choose what X you want for your index by putting that number first. So we're trying to put this in our calculator. So type a 4 first, then you press Math, then you choose the radical with the X on it, and then you enter 10,000, and then you press Enter. Any questions with that? Good? Okay. So go ahead and use your calculator to evaluate these ones, and we'll go around and ask you, and these ones as well. Okay. Okay, so what do we get for A? We'll just start with Ollie, and we'll go to Josie, okay? 4. Okay, good. Jose for B? Can't do it. Why? Well, it's a 7, right? So you can do that one. Okay, that's a good point, though. So this is an odd index, and it's negative, so we're okay. Did anybody get an answer for that one then? We'll come back to Jose. -3? Okay, and then Jose, how about C? There we go. Okay, how about the fraction one? Maddie, what did you get for the fraction one? 6/5, good. If you got 1.2, that's okay, but sometimes they want in fraction form. Okay, perfect. We'll come down. Lauren, what did you get for A? 2.62. So now you're seeing these aren't even ones. So these ones have decimal. That's why I said round the nearest hundredth. Okay? Hannah, how about B? 0.89. Okay, good. And Isla, C? Okay, let's check these with mine here. Good, good, good. This one was a 3. Everything else is good. Okay, any questions of that? That was calculator practice. All right, here we go. So, in terms of labeling, when we're using terminology with radicals, this is what you need to know. The number inside the radical that defines the index, that determines if it's odd or even. That's called the index. Okay? So like when she said, I can't do it, I said, what's the index? Okay? The index is it a square root, a cube root, fourth root, etc. That's the index. Okay? The number inside is called the radical sign. Excuse me, radicand. Okay? The number on the inside is the radicand. The radical sign's on top. The whole thing is called a radical. Okay, so let me say that again. Index, radicand, whole thing's a radical. Any questions on the labeling of radicals? Okay? All right, last page, you ready? All right, identify the index and the radicand of each of the following. So let's just keep on around here. So Denise, what's the index and radicand of A? Yep. Perfect. Okay, Luke, how about B? Okay, Luke, why'd you say 2? Right, if nothing's there, it's assumed to be a 2. Okay, if nothing's up there, it's a 2. That's the default for radicals. Okay, how about Ridge, letter C here?
The index is 3.
Good.
And the radicand is -1%.
Perfect. Okay. Any questions? Okay, here's an important rule here. Okay, this is very, very important. We're going to go through this proof here. What's the, just for, so we understand, what's the square root of 9? 3. Square root of 4? What's 3 times 2? 6, right? Okay, does that make sense? So if I go root 9 times root 4, and we think we're investigating, we think we can multiply the radicands. Radicands means on the sides. That's root what? What's 9 times 4? What's the square root of 36? So is that okay? Okay, so you just learned you can multiply radicands. That right there just proved to you root 9 times root 4 is the same thing as root 36. So you can multiply radicands. Only if they have the same what, you think? Index. Good job, Ollie. They have to have the same index. You can't do a root 2 times a root 3. Okay, those are different roots. Good. So typically, you know, if you can do it with multiplication, you can do it with division, right? So let's check that. Again, that's 3 divided by 2, so we get 3 halves. Are we okay with that? What's 9 divided by 4? Well, we can do it this way. What's the square root of 9 over 4? Well, how do we square root fractions? We square root the top and the, what's the square root of 9? 3, square root of the bottom, 2. So you see again, it works for division. So what we just learned is we can multiply radicands with the same index. We can divide radicands with the same index. Okay, let's check out addition subtraction now. Okay, 3 plus 2, right? That's 5. That's 5, right? Look at this right here. Root 9 plus root 4 is root 13. Is the square root of 13 equal to 5? No, you cannot add radicands. That's why it says not. Okay, see that? We're proving it right now. I'm making sure you understand. You're not just listening to me and nodding your head. Okay? So root 13 is, if we did our estimating from yesterday, root 13 is about 3.7, right? Just under 4. Okay? Okay, same thing here. 3 minus 2 is 1. 9 minus 4, root 5. Root 5 is like 2.2. So again, not equal. So we cannot add and subtract radicands, the rules we just learned. Okay? Questions on those basic rules for radicals? Okay? And the home stretch. All right. So state whether each statement is true or false. So just based on what we did just previously, is this true? Can we do this? Yes. That's good. Here. Yeah, just divide them, right? Root 20 over root 10 is root 2. That's correct. Here.
No.
Good. A way you can check, I was telling my Math 20s this today. The thing we don't understand with radicals, guys, you know like when we simplify a fraction, if I go 4 over 6 equals 2/3, right? If you put it on your calculator, 4 over 6, they're equivalent, right? They're not different numbers. Does that make sense? They're both 0.6 repeating. One's just simplified. Here is the same thing. So real quick here, Ollie, can you put square root 18 in your calculator? And then Josie, can you go root 3 times root 6 in your calculator? And like they should be the same value. Okay, we're not changing anything, we're simplifying. So let's see what they get here. A lot of pressure. Ollie. Just square root. So you're doing just square root. Square root 18. 4.24. Thank you. 4.24. We'll see if Josie, do you get 4.24? Because it's the one above, the yellow. Okay, so there were 4.24 in the calculator for both of them, okay? That's the purpose. So like a good thing to do, for those of you really, like when you're taking an exam, if you're doing a simplifying, take the beginning, put it in your calculator, punch it in, take the end, punch it in. If you got different numbers, whoops, I didn't simplify correctly. Okay, it will not change value, all right? Here we go, write in single radical form. So it means just everything has to be in the radical. So that's going to be 8 times 3, root 24. That's already good. Root 21. This right here, 50 divided by 10, root 5. Okay, so this one I have two steps. I have two radicals. Square root of 100 is 10. So now I have this. Is everybody okay with that step? And then root 10 over root 2 is root 5 again. And then it wants us to go backwards. It says write these as a product of radicals. So now we're going to undo them. Okay, so what's a, Travis, how could I write 77 as a product? Product means multiplications. Right, so I could write root 11 times root 7. That's what they're asking me to do. Okay? 27, Denise, what do you think 27 can be broken into? Yep. Good, root 3 times root 9. And I think we've got everybody today, so I think I'll do the last one. Okay, so then 40, I'll go root 20 times 2. You could have done 4 and 10. You could have done whichever you want, but there you go. Okay, so that's the intro to radicals. Any questions or concerns? All right. Have at it.